Hi, and welcome to Solid Edge 2022. I'm Dan Staples, Vice President of Mainstream Engineering for Siemens. And joining me today is Jeff Walker, who's the Director of Solid Edge Products. We want to talk to you about the many great things that are coming in Solid Edge 2022. But first I want to start with your company and the challenges you're facing. We see that companies are being demanded to be more global, secure, personalized, integrated, and cost-effective. And that really adds up to a lot more complexity. There's really an explosion of complexity. And you can look at that and your company, you can look at that as a problem, or you can look at it as an opportunity. And we can help you with that. We can help you use complexity to your advantage through the comprehensive digital twin, personalized, adaptable, and modern systems, and a flexible, open ecosystem. One of the reasons we're able to do this is our investment. So over the past 14 years, we've invested more than $10 billion in bringing in new functionality to Siemens. And what you see, in fact, Siemens is one of the top 10 software companies in the world. This allows us to bring you Accelerator. Accelerator is an integrated portfolio of software, services, application development platform that really speeds your digital transformation. So no matter what you're doing, whether it's mechanical, electronics, manufacturing, we have you covered. And it all starts with Solid Edge. Solid Edge is your on-ramp, if you will, to digital transformation. And so as I say, you're probably familiar with lots of Solid Edge capabilities for sheet metal, 2D drafting, etc. But maybe you need to go beyond that with the whole Solid Edge portfolio and Accelerator, whether that's managing that data, doing technical publications, simulation, electrical, it's all there for you. And what we see is customers doing amazing things with Solid Edge and the Solid Edge portfolio. For example, Innovates. Innovates is a company in Belgium that makes mobile charging stations. And they're able to take Solid Edge and PADS Pro and use those two together to do great things. As you see, they don't find that level of integration in other engineering software. Another great example is Yanu. They make the beautiful product you see on the left here. What product might that be? Probably something you've never seen before. This is a fully automatic digital bartender. So it can recognize you, make the proper drink, do the proper billing, all contactless, very important today. And I love what Alan has to say. The software has a great holistic design approach, and that's what we like to see and how we can bring you more productive software. So let's talk about Solid Edge 2022 itself. Solid Edge 2022. Engineered to grow your business. There's so much in it, we'll only be able to cover some of it today. Things like Accelerator Share, allowing you to collaborate with customers and suppliers. Or CAD Direct, integrating CAD files directly into your system from other systems and bring them directly into Solid Edge seamlessly. Point Cloud Visualization, big scans of plants, being able to design your equipment in context of that big scan. Solid Edge Design Configurator, a whole new capability to configure your designs quickly and easily for your customers. Now, as we go through our discussion today, we're going to be using two different data sets because there's just so much to see, such a broad range of functionality with Solid Edge. We'll be working with an espresso maker from Fiamma, a company based in Portugal. And we'll also work with a product from Bergner, a company based in Switzerland that makes chemical and pharmaceutical custom machinery. So let's start by talking about mechanical design. And let's start with CAD Direct. CAD Direct lets you seamlessly integrate data from other systems into Solid Edge without translation and automatically take updates. We'll also talk about convergent modeling. We've been working on this technology for several years now. It's getting very sophisticated. The ability to integrate mesh models with BREP or solid models one seamless way. So let's look at that with Jeff now.
Thanks, Dan. First, we'll take a look at subdivision modeling. In this example, we will add support members to the base of the Fiamma espresso machine. The new subdivision bridge command can be used to easily connect edges or faces of subdivision cages and create a lofted structure between them. Here you see an example of that, where we'll select the faces of each subdivision model that we want to loft between. Then we'll add the control curve to help us further define the overall shape. Next, we'll be using the new align to curve command to further define the shape of the part. Simply by selecting the cage vertices to define the direction and then pick the curve, automatically map those vertices to the curve. You can even sketch your own shapes and curves inside the context of the command. Even gesturing is supported for inking of your curves. Here we'll show another option called split with offset to add some pockets to support the rubber feet of the support. A simple selection of the edges with an offset allows you to pull to create the pockets for those rubber feet. Next, we're going to replace the handle with a new design that's been 3D scanned. This result is a mesh model that we import. We can visualize the mesh with the new faceted edge command. In this case, we'll clean up this model a little with the remesh command. Now, faces have automatically been identified and the sketches are added to the planar faces of the mesh. We add a series of cutouts in order to reduce the weight and improve the appearance of the part. Notice the resulting geometry isn't faceted. Solid Edge now seamlessly combines mesh and B-rep geometry in the same body or part. We'll add additional cutouts to reduce the material. Once the cutout is complete, it can be patterned. Finally, we're back in the assembly where we'll replace the current handle with the new meshed handle. But you'll notice the mounting holes are missing from the component. This can easily be solved by doing a Boolean operation using the mesh model as the target and the components from the assembly as the cutting geometry. These new capabilities further enhance your ability to use mesh models in your design process. Now we'll use the new component finder in the Solid Edge Pathfinder and we'll search for the desired filter holder handle, which is designed as a family of assemblies. One of the versions is designed for a double espresso shot, the other is a single espresso shot. Opening the drawing of this assembly, we'll use the new family of assemblies parts list to place a table and detail the parts used for each member. Now we'll look at some enhancements to dimensioning in Draft. Dimensioning to virtual intersections or arcs of rounded edges is now supported. We can also choose to display projection lines to those intersection points. Watermarks are also used to convey important information on the drawing. We'll change the existing one so that it retrieves the document status for the drawing property text. The new CAD Direct command enables us to use foreign CAD data, geometry, and assemblies in Solid Edge directly without requiring any translation. The water boilers that you're looking at here were designed in NX. Once inserted into Solid Edge, they can be positioned just like any other assembly. Since we need two of these, we'll simply copy one to create the second. Notice the boilers aren't quite in the right location. We'll go back into NX and make the changes needed to the mounting bracket such that they'll be in the right position. Since Solid Edge has associative links with NX, a simple update brings the changes in. Next, we'll look at electrical routing enhancements. Solid Edge now supports the display of bicolored wires, allowing us to change the display of this ground wire to be striped green and yellow. Various pattern types are supported as well, including single stripes, helical stripes, zebra stripes, and dashes. And finally, KeyShot, the best-in-class rendering solution, also sees some impressive updates. Decals defined in Solid Edge may be automatically transferred, saving time and effort, which can be seen here on the logos and the cups in the digital scene. Back to you, Dan.
Thanks, Jeff. Lots of amazing stuff in there, but I'm only going to highlight to you a couple things here that I think are real game changers. CAD Direct. So you have the capability you've seen to get an NX assembly into Solid Edge directly, no translation. And when you make edits to that NX assembly, it comes into Solid Edge automatically. There's no extra files to manage. You don't have to worry about that. It's all CAD Direct. And what about convergent hybrid modeling? You saw taking triangle meshes and B-rep solid model, pulling that all together into a single cohesive model, significantly reducing your design time. Let's talk about some other mechanical design enhancements, some other great things in here. Point clouds. It's becoming fairly common to be able to scan an entire plant or factory and bring that data forward. We can now bring that data into Solid Edge so that you can design in the context of that factory or plant. What about large assembly modeling? We see people first building parts, then assemblies, then whole factory lines. Assembly modeling in Solid Edge keeps getting faster and faster and faster, best in the business. And synchronous radiate, an amazing new command within the synchronous modeling environment that allows you to deal with radially symmetric parts and edit those effortlessly. So let's take a look at that now, Jeff.
Thanks, Dan. Well, the first thing we'll do is we'll take a look at a new assembly preview mode. This mode allows you to very quickly open solid edge components and very large solid edge assemblies lightning fast. In preview mode, you can manipulate the view, show and hide components, and apply display configurations. In this case, we'll isolate the most critical part of the model that we want to edit using a configuration. Then we'll simply tell the system how we want to open, and open only the components that are to be edited, saving you time and memory. Another time-saving enhancement is the gusset command. We now allow you to automatically add gussets to a frame structure. Here you can see the user interface. You can define these gussets in any shape and size that you desire. Then you simply select the frame element, position where the gusset is to go, and the system automatically creates the component there. If we continue down the internal components theme that we introduced in the last release, we now allow you to create an internal component and actually create the model geometry directly inside the solid edge assembly. We've introduced this new assembly modeling capability that gives you the ability to create the entirety of a design without any need for an external file. Here we have a pneumatic cylinder which will be imported as an internal component. We need to add a bracket to this assembly, but since it's a purchased part, we'll just create this as an internal component. And again, saving the need for external tracking of files. If you'll notice during sketching, a pop-up menu allows you to quickly access commands that are relevant to your selection. And this is new for Solid Edge 2022. So we've defined our sheet metal part. We've also will have to give it a material definition and a gauge definition. In addition, we're able to create geometry and reference the components from the assembly, whether they're internal components or they're real components in the assembly. So again, we're defining the material gauge for the sheet metal component, and we've defined this component completely inside the context of this assembly. You're also able to drag the component, doing animations using both internal components as well as the real component combined. The new component finder speeds up the process for locating parts within the assembly. You simply key in the name and it finds the list quickly. Here we found a shaft, and we use the new radiate command to edit the radius or the diameter of the shaft component. You simply select the shaft, putting the component in the select set that you wish to change, and then Synchronous does the rest. In this particular example, we want to include the pocket in the radiate and the offset option. Simply selecting that pocket and including it allows that to be done. A new assign capture fit command allows relationships to be predefined on a component while in the context of the part. Here you can see that capture fit relationships already exist. We'll add a new capture fit to the collection and save it to the component. When I place the handle into the assembly, all you have to do is select the component and select the mating components that you want to mate it to, and the handle automatically snaps into place. It's as easy as that. Here's another example where we have a handle that needs to snap to 5 new locations. Again, the assign capture fit makes it easy. Solid Edge now has the ability to place point clouds within the context of your design. This allows you to reference and visually indicate where your components will be placed inside a large assembly. Solid Edge supports multiple point types and then allows you to position your component inside the context of the plant design. The point cloud can be easily repositioned. Clipping planes can be used. You can even measure to the location of the point clouds relative to your design. Here you see that the tank component was in the wrong position and it was moved to match the point cloud and the plant definition more precisely. And that's it, Dan. Back over to you.
All right, thanks, Jeff. So many great things to see in there. But again, something I really want to highlight to you is a game changer. Point cloud visualization. The ability to take scans in, gigantic scans, millions or billions of points, and be able to look at those in the context of Solid Edge and be able to integrate your design directly in there and design in context of that point cloud. As you can see, they're full color, they give the full feel of the plant or factory. Really amazing stuff. And we see that our customers really love this new technology. So Benjamin at Bergner, for example, eliminate a lot of tedious manual effort. It's just so much easier with the new point cloud technology. And what about large assembly modeling itself? Order of magnitude increase in large assembly modeling performance. So you have that preview mode where you can very quickly bring up the assembly, very, very massive assemblies, decide what you want to work on, and then just bring in that bit of the assembly. really improve your productivity. And we see that folks are already taking advantage of this. Our beta customers have been using this, like Luca Carminati at CMS. Much, much faster work, save a lot of work on their designs. And what about synchronous radiate? Really amazing stuff if you're working on those axisymmetric parts. Being able to make edits without having to do any extra effort happens almost magically. Great stuff. Okay, next up is Solid Edge Design Configurator. I'm very excited about this. If you're doing any engineer, configure to order type of products, the ability to very quickly change your designs and have new quotes very quickly. Let's take a look at it with Jeff.
Thanks, Dan. The new Solid Edge Design Configurator allows you to design multiple product variants directly in the context of Solid Edge. In this example, we'll configure a variety of conveyor designs. The first step is to select the component to be configured. The next step is to define the master input parameters of the configuration. In this case, it's the length and width of the conveyor plus the pitch of the rollers. Values can be easily added for any parameter, and the images can be included in order to help the end user identify the needed inputs when configuring the model. Defining a new input parameter for the pitch of the conveyor, we will quickly configure the name, type, label, and render style to use radio buttons. The pitch value of the conveyor can be customized between 60 and 90. However, since different lengths of the conveyor require different pitches, visibility rules need to be applied. This is done by making use of a simple expression to define the intelligence. Here, the rules are being validated to ensure the consistency and proper definition have been made. Here, the function is going to be copied and pasted to allow you to easily reuse formulas without having to include them again. Skipping to the last step of the configuration, we can see the configuration form is properly created. Next, defining the rules for the process. Here we have multiple rules to drive and configure the connectors at the bottom of the conveyor. We will use a combination of simple condition and expression rules and a truth map table to work out the number of positions of the connector. All rules can be quickly validated. Finally, we specify the actions to be taken. Here, variables are set and components are replaced to satisfy the input parameters. A rename model action will ensure our final assembly will be renamed appropriately and also create the other necessary outputs, for example, a step file as shown here. Now we can run it quickly and create as many configurations as needed. A newly generated configuration can easily be shared with Pack and Go. The configuration logic is all stored within the CAD model. There's no need for any further plugins or external resources. And with that, Dan, I'll hand it back to you.
All right, thanks, Jeff. So as you see, with the Solid Edge Design Configurator, you can accelerate your configure to order and engineer to order processes and create compelling sales proposals. You're also going to see that it really error checks for you and it creates a nice dialogue for your users to interact with so you can very quickly configure new products. What about CAM, Solid Edge CAM Pro? Tried and true technology developed over the last 40 years. A lot of users using it today and enjoy the benefits of it. But what if that technology was available to all of you, all Solid Edge customers on maintenance? That's what we want to introduce to you today with Solid Edge 2022. Jeff.
Thanks, Dan. Here we'll be using Solid Edge CAM Pro to create the manufacturing toolpath for the rear legs of the Fiamma espresso machine. First, we'll use the Solid Edge assembly tools to create the shape to represent the stock parts, and also the parts that form the fixture assembly, which includes the standoff plate as well as additional fixing holes from the standard database. We will also make use of supplier catalog in 3D Find It to get the appropriate socket head cap screws to be used to fix the component in the fixture. So as you can see, Solid Edge is a great CAD for CAM tool. We'll need to machine this in two separate steps. Step 1 is to mill the pocket and drill the holes, and step 2 is to machine the profile. One click will send the entire assembly to the Solid Edge CAM Pro application. Note that associativity is maintained at the complete assembly, so if there are any last-minute changes, we can quickly update them and continue the NC programming process. New for Solid Edge CAM Pro is the ability to create adaptive roughing toolpaths for 2.5-axis operations. This is included at no additional cost. These are faster than traditional toolpaths and extend the cutting life of your tools. Notice the advanced graphic capabilities for validating your toolpath. Here we'll create spot drilling operations for the 5 holes in the support. Notice that the graphical pop-up hints that help us with operation selection. Graphical helps are also available for geometric selection. Each time we select a hole, we get a preview of the machining that will take place. Again, at any point in the process, we can get visual feedback on our decisions. Now that our CNC program is complete, let's run through the whole visualization process. Notice you get to completely visualize the entire machining process before committing it to machining. Of course, no job is finished until it has been post-processed for a specific machine. That's where PostHub comes in. It's an online database of over 1,200 post-processors. You can easily filter and find exactly the one you need. Also, PostHub is constantly updated, bringing you the most recent tools. And Dan, with that, I'll turn it back over to you.
All right, thanks, Jeff. I'm really excited about this. There's a great heritage in Solid Edge CAM Pro and our machining technology over the last 40 years. Many people enjoying that technology, but now every Solid Edge user who's on maintenance can enjoy that technology and work with Solid Edge CAM Pro. Next up is Accelerator Share. I'm super excited about this. It's a functionality in Solid Edge that allows you to collaborate with colleagues, suppliers, customers very easily. Nothing for you to set up, works on all sorts of devices. So let's take a look at that. Jeff.
Thanks, Dan. Accelerator Share allows you to import your CAD models into a secure cloud location. Within that context, you can view, you can rotate, you can show hide, you can 3D section, you can even do measurements and markups. Here, a reviewer has identified the need for some change in the design. The location of the change is identified by a sticky note and a place describing the needed change. Accelerator Share offers maximum traceability, as all markups are recorded, enabling conversations back and forth on any of the issues you're tracking. It also records who made the markups and when it was made. We can also easily go back to the markups at any time. Simply save your markups and send them to the designer for review. With Share, you can also directly connect to Solid Edge, synchronizing your data from your desktop to the cloud. Here we have the same project on our desktop. It's represented simply as a folder. Any data that we have in this folder will get synchronized in the background. In Solid Edge, we can securely sign in to Accelerator Share and see those same cloud-based projects. The Espresso machine can be opened and we can go right to work on the part in question. The designer can easily access that same markup in the cloud directly from within Solid Edge. Once completing the change, another markup continues that two-way conversation and collaboration with other stakeholders so that the issues are tracked appropriately. Another great feature of Accelerator Share is the ability to share a project with anyone. Simply enter the email address of the person with whom you'd like to share and choose their access permission level. Here we can choose View, or View and Download, or Edit and Download, depending on how you want to protect your intellectual property. We'll share this design with one of your colleagues and our customers and give them the appropriate access. Finally, with the Share Augmented Reality feature, you can see exactly how your designs will look in the real-world environment. Snap the design onto any surface seen in the camera lens at the correct scale. The finger gestures can be used to manipulate the model and easily visualize what your design looks like in a real environment. So back over to you, Dan.
Thanks, Jeff. All right, Accelerator Share. Really great stuff. Next generation cloud-based collaboration that allows you to work inside your company with colleagues or work with suppliers, work with customers. Nothing for you to set up. Works on every device. So whether you have a Mac or an iPad or a Chromebook, it works on all those devices with no special setup. And you saw the ability to write notes that are automatically converted to text, share those markups. Very exciting stuff. Next up's dynamic visualization. You make complicated products, large assemblies. How do you know which parts are from which supplier? Or which parts are of what material? Dynamic visualization will help you with that problem. Let's take a look at that now with Jeff.
Thanks, Dan. Dynamic visualization gives you the great capabilities to generate visual reports of your assembly. So what we'll do here is we'll open a solid edge assembly using Teamcenter Active Workspace. We'll create a visual report based on the component supplier and the material definition. So the first thing you'll do is you'll add columns to the user interface, those columns that you want to filter on. Here we've added suppliers and material. So for each of those, we'll filter on the particular material and the particular supplier that we're interested in visualizing. So once the rule is created, you simply apply the rule and the model changes display to show you the rule definition. And here you can see in red the components based on that supplier and that material selected. You can also export these rules and import them into various assemblies. Here we have a rule that allows us to identify which user created which components. We'll modify that rule to allow us to identify work in progress as well as components that are created by Pat. We can highlight those, select those, and then go into edit mode. Here we'll see we need to add a warning light to this box. We use 3D Find It to find the particular light from the particular supplier that we want. Once we've identified the right one, we'll generate the component in Solid Edge. But in this case, the component already is contained in the Teamcenter database. So instead of replicating that in the database, we'll simply reuse what's already there. Also in Solid Edge 2022, we were able to take advantage of the project definitions within Teamcenter. Here we can see we've assigned the components to a particular project in Teamcenter. The Solid Edge built-in data management also supports dynamic visualization. Here again, we'll display the assembly coloring based on the material type to ensure that we have the proper materials throughout the model. So again, the rule is applied, visually it's displayed, and you'll notice that the red handles should be green. Those should be stainless steel and not aluminum. So we'll send those back to the designer to be reworked and the proper material to be applied. So once applied, we can then do an auto update of the status, and the system will automatically show us the status and then update to get the latest component. In this case, the handles are updated with the proper material. We will rerun the same rule, and you'll see that now the handles are green and therefore in the correct material. Another nice enhancement is that we've modernized the file properties dialog. And you can see here it looks much more user-friendly and lets you easily create new custom properties as shown here. This next example will use replace part with 3D Find It. 3D Find It has the ability to take a component and use that component geometry to search the catalog database for similar components. Here, once the component is found, we identify the supplier that we desire, and with a few simple clicks, that component is inserted into the assembly, replacing the previous geometry. And lastly, we've added Pack and Go directly to the Windows Explorer UI, making it easy for you to share your data without having to open the assembly within Solid Edge. And that's it, Dan. Back to you.
All right. Thanks so much, Jeff. So many good things you saw in there with 3D Find It and the ability to replace components, search directly using geometric shapes, and so on. But I want to highlight to you this dynamic visualization. Being able to say, well, what supplier do I have for the different components? Color code for me all the things that are stainless steel. Color code for me all the parts that are in work. Amazing technology that would save you a lot of time and money. Next up is Solid Edge Simulation. We have some great enhancements in there, some game-changing enhancements in terms of the ability to remesh parts using the body mesh command, and some other great tools. Let's take a look at those, Jeff.
Thanks, Dan. We'll start by looking at a new boundary condition allowing the user to apply hydrostatic pressure to a model. So we'll apply a configuration that gives us the geometry of interest. Here we want to look at this tank on the left and do an analysis, assuming that tank is filled with liquid. So we'll create a hydrostatic study, and in the definition of the loads, we'll use the new hydrostatic pressure command. All you have to do is to identify the surface to apply the load, identify the depth of the liquid in the tank in this case, and then provide the density of the liquid within the tank. Solid Edge will do the rest. To finish the analysis model, we'll apply constraints to the bottom of the tank and then perform the meshing and analysis as needed. Notice on the new mesh dialog a body mesh. This is proprietary technology from Siemens that does a really good job meshing complex models. Some things that couldn't be meshed before can now easily be meshed much quicker and much more reliable than in the past. So here you see the result of the hydrostatic pressure load in this tank. We'll change the liquid level in the tank and run the analysis again just to validate that this tank will withstand the pressure exerted on it in production. There you see the animation of the stresses, and they show up in the obvious place at the bottom of the tank where you might expect. Another great enhancement we have in simulation for Solid Edge 2022 is improvements to beam meshing. Here we're taking a frame structure and creating beam elements for the finite element analysis. Notice that the rigid connectors were automatically placed. We've improved significantly our ability to create those connectors automatically without any user intervention. Here the user has selected the bottom and changed some of the parameters to get the rigid connections correct. The bottom of the frame is then fixed, loads are applied, and the analysis is run. Once complete, you'll see some enhancements to the output, to the post-processing for this model. We now can post-process and display contours using von Mises stress, and we've also improved factor of safety stress contours based on those same von Mises stresses. Now back to the assembly, we're going to do another analysis on the pin within this assembly. You notice this pin is a mesh model. Simulation can now perform analysis on mesh models. You simply apply the boundary conditions, the loads and constraints where needed, and run the analysis. Here you see the result for the pin on this mesh model. And with that, Dan, I'll turn it back over to you.
Okay, thanks so much, Jeff. Lots of great new things in there. Obviously, the hydrostatic pressure load takes a lot of work out of the process for you. The way the beam elements are automatically connected together, great stuff. But also that body mesher. You can take a mesh that's very irregular, very difficult, and remesh it with the body mesher. It's a game changer for analysis. Next up is SimCenter FlowMaster for Solid Edge. If you're doing any types of products where you have piping and you need to do analysis on the piping or design on the piping and the flow within the pipes, SimCenter FlowMaster for Solid Edge is for you. Let's take a look at how it works with Jeff.
Thanks, Dan. The unique CAD to FlowMaster technology extracts the geometry from Solid Edge assembly and automatically creates the corresponding fluid volume that exists inside the pipe runs and components. During the process, a face can be selected to give the length scale and convert the system to a subsystem. The abstraction process is fully automated. There is also full control over the fidelity of the model, which can be adjusted with the slide bar. Individual elements can be inspected, deleted, and merged. Once the network configuration is defined, the geometry can be exported to FlowMaster. Following export, the file will be saved for reuse, then automatically opened in SimCenter FlowMaster for Solid Edge in the Subsystem Import Wizard. The CAD geometry, centerline, and component connections can be seen in the wizard, and the model can be rotated to the desired projection when the network is created. On selecting Import, a new subsystem will be created for review. The entire subsystem can be used to create a model, or individual pipelines can be extracted into their own subsystem. For a flow analysis of this model, we are going to extract the pipe from the two compressors to the center vessel. We create a second subsystem from the first and save it in the subsystem catalog. We'll now add the subsystem to a new network and specify the boundary conditions using pressure sources. We'll specify the compressor outlet pressure and vessel inlet pressures. For this low-pressure system, we'll specify air as the working fluid and run a static simulation. Following the simulation, we can look at the results for individual components or look at the whole system using network visualization. With this, we can quickly oversee flows, pressures, and velocities. Next, we'll look at the effect of a pressure pulse from the compressor on the system. We'll specify curves defining the pressure pulse and the source, and then run the transient simulation. Following the simulation, we'll look at the flow into the tank, where we can see the effects of the pressure pulse from the compressor. Then, moving to the compressor outlet, we can enable transient visualization to see the variation in flows, and that the larger flow is from the left-hand compressor. And back to you, Dan.
Thanks, Jeff. Some super advanced technology there that we're happy to bring to the Solid Edge community. This is one of the advantages of the Accelerator portfolio, the ability to bring advanced technology to you. Great capabilities here in terms of easily modeling and analyzing the fluid system. The great extraction of the center lines automatically from the 3D geometry, so you can go straight into that analysis and see what's going on with your system. So that was a feature-packed release, right? We went through a lot of stuff, many things in Solid Edge 2022 that are going to help your business. FOCA has to say, there's simply so many amazing things in there. The number of improvements are enormous. And I think that's been echoed by all of our beta customers. Everyone is saying, this is the best release of Solid Edge ever. And so much more. We were able to show you a lot of great things in Solid Edge 2022, but there's so much more to see and learn about. And I invite you to do that. I invite you to go to this link, siemens.com/solidedge2022, or scan the QR code and learn about the rest of Solid Edge 2022. I also invite you to get involved. We have a vibrant community around Solid Edge. There's blogs that talk about those new features and how to use them in your company. There's other users in the community who can help answer questions, or you can help lend your expertise. My team is often in there to help answer questions and just to talk with our users about how things are going. So I invite you to join the Solid Edge community today, and you can do so at this link, community.sw.siemens.com. Solid Edge 2022, engineered to grow your business. Whether you're a company like Bergner, Yanu, Fiamma, or Innovates, Solid Edge 2022, engineered to grow your business.